DeepMind's latest AI just designed molecules that don't exist in nature, and some of them are toxic. Not by accident. The researchers were testing whether the AI could generate dangerous compounds if they removed the safety guardrails. And it did, within seconds. Now, here's the thing nobody in mainstream coverage is talking about. This isn't a hypothetical anymore. We're not debating whether AI could theoretically design bioweapons. It can. It has. And the gap between a cutting-edge lab in London and someone with a laptop is closing faster than governments can regulate it. Let me back up and explain what's actually happening, because the stakes here are genuinely different from other AI risks we talk about. For decades, designing new molecules was slow. You'd need a chemist, years of education, access to a lab, trial and error, failed experiments, wasted reagents. The barrier to entry was high. That friction kept dangerous knowledge somewhat contained. You couldn't just decide to engineer a pathogen in your bedroom. But AI molecule design flips that on its head. Tools like AlphaFold and its successors can now predict how proteins fold and function. They can design entirely new proteins from scratch. And crucially, they can do it in minutes. For free. With open source code. The dangerous part isn't that AI is smarter than chemists. It's that it's faster, cheaper, and it doesn't care about consequences. An AI doesn't have intuition or ethics built in. It just optimizes for whatever you ask it to optimize for. If you ask it to design a molecule that's lethal and heat-stable and easy to synthesize, it will try. It doesn't judge. It doesn't have a conscience. In 2022, a team at MIT actually tested this. They retrained a drug discovery AI to generate toxic compounds instead of helpful ones. In under 6 hours, it designed 40,000 novel molecules, many of them extremely dangerous. The researchers published this on purpose, to sound the alarm. They wanted governments and labs to wake up. Some did. The US started tightening export controls on AI models. The EU started talking about AI regulation. But here's the problem. You can't uninvent this. The science is out there. The code is open source. A determined actor with basic programming skills and access to a GPU could, theoretically, use publicly available tools to design something genuinely harmful. Now I want to be specific about what we're actually worried about, because there's a spectrum here. The first tier is things like novel antibiotics or cancer drugs. Those are hard to synthesize, require infrastructure, take time to manufacture. Lower risk of weaponization. The second tier is pathogens, viruses, or bacteria that could be engineered to be more transmissible or lethal. This is where the real fear lives. Because biology is different from chemistry. A virus, once released, replicates. It spreads. You lose control of it immediately. One person designing one pathogen could, theoretically, affect millions. And the third tier is the one that keeps biosecurity experts up at night. What if the AI doesn't just design a dangerous molecule, but designs it in a way that's optimized for a specific outcome? What if it creates something that's lethal to a specific genetic population, or resistant to every known treatment, or incubates silently for weeks before symptoms show? That's not science fiction. That's the logical endpoint of an AI that's really good at optimization and has no ethical constraints. So what are governments doing about it? Actually, more than you'd think. In 2023, the US issued an executive order specifically addressing AI-assisted biological threats. The National Institutes of Health started requiring biosafety reviews for AI research involving pathogen design. The UK published a biosecurity review. The EU is working on rules. But, and this is important, most of these measures are voluntary or apply only to research institutions. They don't apply to private companies. They definitely don't apply to people outside the US or EU. And they almost certainly don't apply to bad actors who don't care about the rules. There's also a coordination problem. If you make the rules too strict in one country, the research just moves somewhere else. If you try to control the code, it leaks. If you try to control access, open source versions pop up. It's like trying to put the genie back in the bottle, except the genie is mathematics and everyone has a copy. So what's the realistic outcome here? Most experts I've read think we're heading toward a world where AI molecule design is treated like nuclear technology or cryptography, heavily regulated, export controlled, restricted to credentialed institutions. You want to use a powerful molecular design AI. You need government permission, background checks, regular audits. But that assumes governments can actually coordinate and enforce that. History suggests they can't, not perfectly. The more likely scenario is that we get some level of regulation in wealthy countries, a patchwork of rules everywhere else, and a constant cat-and-mouse game between security researchers trying to lock things down and people trying to break in. What actually keeps me up about this is the asymmetry. A bioweapon is asymmetric by definition. It's cheap to make, easy to deploy, hard to defend against, and the damage is massive. For most technologies, the more advanced it gets, the more expensive and difficult it becomes. Not biology. Not with AI. Here's what I think matters to you, watching this right now. This is a moment where the public should actually care about AI policy. Not because it's trendy or because everyone else is talking about it, but because the decisions made in the next few years about how we regulate molecular design AI will genuinely affect biosecurity for decades. If you want to stay informed about this stuff, the real risks, not the hype, subscribe. I dig into the actual science behind these stories, and this one's too important to let the headlines do the talking.